Hi everybody, welcome back. Today we're going to talk a little bit more about circles in the coordinate plane, chapter 10.7 in our textbook. And our two objectives are going to be to graph equations of circles. Our second objective is going to be to complete the square to find the center and radius. Completing the square is a technique that you learned in Algebra 1, and we will go ahead and review that so that you're able to find the center and radius of a circle. So let's get started here. So for our first example, we are going to be given a standard equation of a circle. So as you recall from yesterday, we have this standard equation, x minus h squared plus y minus k squared equal to r squared. So what we are going to do is use that to figure out what our center is. So if you recall, we had to reverse the center yesterday in order to be able to find, or in order to be able to write this standard equation out. So we're going to follow that in the same way. We are going to go in reverse, and this plus 2 right here is going to tell us that we are going to have a negative 2x coordinate for our center, and right here at minus 1, we are going to have a positive 1 y coordinate for our center. And at the very end, this is where we have our r squared portion of our equation. So there, in order to figure out what r is, we're just going to take the square root of that number, and we will get our center and our radius. So as you can see here, we will have negative 2, comma 1, and our radius is 3. So when graphing that, we are going to place our center at negative 2 comma 1 on the coordinate plane. Since our radius is 3, I am going to just count out 3 spaces in each direction. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And using a compass, we would draw a nice circle that looks something like that. So finding the center and the radius, and then just going ahead and graphing that on a coordinate plane. All right, I want you to try this problem out. So go ahead and pause the video for a second and find the center and the radius and graph it on a coordinate plane. All right, so hopefully you gave that a shot. Now notice for the x squared value, we don't have our typical x minus h format. So all that means is that our h is actually 0. So it's actually x minus 0 squared, and it's been simplified. So with that said, our center is going to be 0, comma negative 3. Our radius is radical 16, which is 4. And we get our circle here centered right at 0, comma negative 3, right on the y-axis, straight down. Okay, so let's go ahead and move on here. All right, now we're going to get into the technique that I mentioned a little bit earlier, which is called completing the square. All right, so now you learned this in Algebra 1, and you mainly used it to find the vertex of a parabola, but we can use it to find the center of a circle. So these are the steps, so pay close attention. All right, so step number 1, we are going to group our x and y terms while also isolating the constant value. So what that means is this minus 16 here, we're going to send over by itself on the right by adding 16 to each side. And notice I also grouped together my x terms, x squared minus 8x, and I purposely left a space here. And I'm grouping my y terms together and purposely leaving a space here. That's our first step. Okay, our next step is going to be actually completing the square. So when you complete the square, you take half of your middle term here. So in this problem, you're going to take half of this term right here. It's that b term, that negative 8. That b term. Half of negative 8 is negative 4. And what you're going to do at negative 4 is you're going to square it. That is going to give you 16, which I will show you in just a little bit. Now, on the y portion, half of this b term, which is 4, is 2. And you take 2 and you square that, and that's going to give you 4. All right, so now you will see on the next slide, we are going to actually add that number of 16, and we're going to add 4 into those spaces that we left. But remember, when you add something or subtract something to one side of an equation, you must do it to the other. So here, I am also going to place 16 and 4 on the right side of the equation just to keep it in balance. You're not allowed to do something to one side of an equation and totally forget about the other, so make sure you do it to both. All right, so now the purpose of this is to create two perfect square trinomial factors. So as you can see, once you take this equation here, you can now easily factor it to x minus 4 squared. So think of it like this. It's like doing one of these x factor problems we talked about. 16 on top, negative 8 on bottom, and getting negative 4 2 times. That would give you two factors of x minus 4, which written in a simplified form would be x minus 4 squared. You might also recognize that this is a perfect square trinomial from Algebra 1, which is another topic you learned a while back. But if not, the x factor works just fine. On the y portion, this would be the equivalent of us having 4 on the top, 4 on the bottom, and multiplying 2 times 2 to get 4, and adding 2 plus 2 to get 4. And that will create this factor that you see down here, y plus 2 times y plus 2, which simplifies to y plus 2 squared. And then over here on the right, all of that adds up and gives you 36. And then you will notice that you have that nice familiar format of that standard equation of a circle. The whole point of completing the square is so we can get our standard equation of a circle just like this. And you'll notice now I can easily identify the center and the radius. So, very last part of this problem is look for that center. So here, remember that's x minus 4, which means that our h is 4. And then we have y plus 2, which means that our k is negative 2, and that's our center. 4 comma negative 2. At the end, we take the square root of that number, square root of 36, which does give us a radius of 6. So a lot of steps, but as long as you remember you're completing the square, something that you guys can definitely handle. So please try this problem out. It does involve completing the square. And pause the video for a second and try it out on your own, and check back in a moment, check back in a minute or two for the solution once you're done. Okay, so this one I'm going to speed through much faster than that example, but I will explain the steps as I go. So here, just as in our initial problem there, you've got to isolate this constant, move it over. You see you get minus 9 on this side over here. And we group our x and y terms and leave a space because you're going to have to complete the square. All right, so now we're going to take half of negative 8, which is negative 4 again, and square that, which is 16. We're going to take half of 6, which is 3, and square that, which is going to be 9. So we are going to add 16 and 9, again, to both sides. Don't forget to add it to the right side as well. All right, now we are going to factor that. Again, 16 here, negative 8 is negative 4 and negative 4. You might notice that your half of b, this half of b number here, is what ends up in your parentheses. So keep that in mind. That may be a little bit of a shortcut for you. Here, 9 and 6 will be 3 times 3 gives you 9, 3 plus 3 gives you 6. And again, notice this number here, that 3, is what ends up in that parentheses there. All right. We add up this side, negative 9 and positive 9 actually cancel out and leave you with 16. All right. That leaves us with a center of positive 4. So we just basically reverse that sign. And the y value of our center is negative 3. 4 comma negative 3. And then at the very, very end here, remember, again, take the square root of that, and that gives you 4. All right, I have one more practice problem for you to try out. So once we get to the next slide, please pause the video and then give it a shot. Okay, so here you'll notice that you don't have a single a linear y term. In other words, you have x squared and you have a positive 16x, but for y squared there is no y term. So in this case, again, I'm going to go through this a little bit more quickly, but first of all, notice your constant's already isolated, so that's going to leave you with just negative 55 on the right. But now when I rearrange my equation, notice I don't have to worry about y squared at all. So in other words, I just need to arrange my x terms, leave my typical space here. Then for the y squared, there's nothing I need to do. Okay, I'm just going to write plus y squared. We complete the square on this side here. Half of 16 is 8. 8 squared is 64. That factors to 64 on top, 16 on bottom. You get 8 and 8. Remember, these are called perfect square trinomials. Again, a shortcut, you'll notice half of b is what ends up here in your parentheses. All right, there's nothing to do for y, so we're going to leave y squared. Over here on this side, simplify negative 55 plus 64, and that'll give you 9. All right, so all this means is that you are going to have a center of negative 8, and you're going to have a y value of 0. So remember, this is equivalent to y minus 0 squared. It's been simplified. Y minus 0 squared has been simplified to y squared. So our center is negative 8 comma 0. Again, right here at the end, take the square root of the 9, and that's going to give you 3. Okay? All right, so that wraps it up for our lesson today. If you want one more example, please go ahead and just like yesterday, I told you to go ahead and check out that video that MC Ireland created called Circle Mode. And he goes over one more example here, so I'm going to play a short clip for you. Right at about the 1 minute and 34-second mark, he talks about completing the square problem.
Complete the square from algebra 1 and 2. I might take all the x's and y's and put them in a group. Isolate the constants, what you must do. Take half of these terms, power of deuce. Add these squares to both sides and then produce a factor form of 8 from the center.
So please go ahead and check that out. I think that's going to be very helpful for you guys. And let me know if you guys have any questions. Send me those Schoology messages or Google Classroom messages or email.